questions. Okay, na? These days you aren't asking question in the patch. Huh? Make sure you ask questions. Okay. Sorry. Hey everyone. Hey Mustafa, Abu Bakr. Okay. Please turn your cameras, all of you. Duha, Abu Bakr, and Priyanka. So guys, so far we had learned about earthquakes. Right now we had learned about the earthquakes and we had learned about the cause of the earthquake also. Right now, behind the cause of the earthquake, we have learned that our Earth outermost layer is basically crust right now, and that crust is fragmented into tectonic plates. There are major tectonic plates and then there are minor tectonic plates. In total, we have learned that there are 7 major tectonic plates, also called as basically tectonic plates. Okay, then we learned further about the composition of different layers of the earth also. Right now, particularly about the core, we have learned that it is made up of nickel and iron, and core is the hottest zone, hottest part of the earth's surface. Temperature here can reach up to 6000 degrees Celsius. Right now, that is almost quite similar to the surface temperature of the sun. Okay, due to the intense amount of heat, what happens, this sets convection current in the mantle. Due to the intense amount of heat being coming out, 1 second. So due to the intense amount of heat coming from the core, what happens, it sets convection current in the mantle. So meaning that mantle is actually in movement, not like flowing water, but it's actually in slow movement. So this slow movement of the mantle actually sets the tectonic plate into movement. Right now, that is the reason behind movement of the tectonic plate. Okay, and these tectonic plates are huge land masses. Right now, they are huge land masses. Okay, since they are in motion, so sometimes they will. Sorry. So these tectonic plates will crash into one another, move apart from one another, or slide past one another like that. Okay. So this movement of the tectonic plates will release tremendous amount of energy. And that tremendous amount of energy travels in the form of seismic waves. Doha, turn your camera on. Priyanka, Abu Bakr, turn your cameras on. What do we call the origin of the earthquake? Repeat again.
So
Priyanka?
focus.
Focus. The vertical point just above the focus?
Epicenter.
That is epicenter. Good. Earthquake. Earthquake travels in the form of
Seismic waves.
Seismic waves.
seismic waves. Good, everyone. Okay, why I have taken this picture here? Which continent is this? Any idea?
Africa.
Africa, right? Africa is recently in news also due to some very bad reasons, right?
Yes,
You
sir.
guys would be aware. See, in the upcoming few lakhs or few millions of years, there will be separation of huge landmass from the Africa. Okay, no? You guys look over here. These are the fault lines that have been created over here. If you were to look at the aerial maps, the satellite maps of Africa, so here we will see that there has been huge fault lines, huge cracks have developed. So actually, what? Sorry, please give me 1 minute. I think I will have to take some warm water. Okay, now 1 second, please. Yeah. So I was saying that in the upcoming, like probably 1 lakh year, 2 lakh year, or maybe 5 lakh years, no one knows how much, but there will be separation of this piece of landmass from this African continent. So this basically tells us that the tectonic plates are in movement. Actually, we can see an example of the movement of the tectonic plate over here, right? So that is one thing. Then we learned that this earthquake will lead to loss of life and property. Okay. Then there are possible causes for earthquake other than the tectonic plate movement. It could be due to volcanic eruptions also. right? And it could be due to some nuclear test also being whether it is being carried under the ocean or whether it is carried on the land. While it could be due to some man-made activities also. If some man-made activity is being done on a very large scale, so it can actually kind of disrupt the geography of the area and may trigger a very small earthquake that may even go unnoticed also. Okay. Now we know that other than Earth, there are some other celestial bodies, like there are others rocky bodies also in the universe. Right now, there are some other rocky planets also in the universe, isn't it? In the solar system, particularly. So, just like here on Earth, we are having a quake called as earthquake. So, can there be quakes on other planets too? What do you guys think about it?
Yes, sir.
Right now. Hmm. So it is true that there are quakes on other planets too. On other planets also, just like here on Earth, we have earthquakes. So suppose if it is on Moon, so that will be called as moonquake. And what are the evidences of it? So following are some of the evidence. Right now, like 1 or 2 years ago, I think this Chandrayaan 3 mission was sent to the moon and it detected moonquakes. Huh? In fact, it recorded somewhere around 200, more than 250 plus seismic events. Right now, it's just moonquakes occurs there also. Okay. I think you guys will be able to recognize these images. Any idea what are these images of? Particularly the first one.
Sir, nuclear bomb.
Hmm. These are, but
Nuclear.
uh, what were these nuclear weapons? Like, what were the names of the first two nuclear weapons here? One is the
Was
Fat
it?
Man and Little Boy,
Yeah, little.
right? The first one being Fat Man, the second one being Little Boy. Okay. Look how cute the names are, but how devastating these things are, right? So these nuclear weapons will also cause earthquake. Okay. Now let us understand about the power of the earthquake. Okay. So the power of an earthquake is expressed in terms of magnitude on a scale. Is expressed in terms of magnitude on a scale. You guys are well aware that scale is called as a Richter scale. Okay. That scale is called as a Richter scale. Okay. Here you can look at the Richter scale. Like basically this is basically the table where the magnitudes are written from 1 till 10 over here. So if an earthquake is having a magnitude of more than 7 on the Richter scale, so that is usually considered to be very destructive. Okay. If it were to be, for example, if it were to last for more than a minute, so there'll be loss of so much of life and property in that place. Okay. Suppose there's an earthquake of magnitude 1. Okay. So this kind of earthquake actually occurs on a daily basis. On a daily basis. In fact, if you guys were to go through the data, on an average, there's 20 earthquakes daily. Okay, na? On an average, there is around 20 earthquakes daily. For example, if you were to consider some of the places, for example, like Philippines. Okay, so in Philippines, there can be around 20 earthquakes on a daily basis. So you guys will say that if that much of earthquake were to be there in Philippines, so that country must be in ruins. Huh? So actually, the thing is that not all those earthquakes are of a strong magnitude. All of it on your cameras on. Now, why should I repeat this same basic thing in every class? Huh? All of it keep your cameras on. Abu Bakr, turn it on. Priyanka, you also. Right. So smaller earthquakes are very frequent. Actually, they'll be almost occurring on a daily basis. In some places, there can be as many as 20 earthquakes on a daily basis. Hmm. Okay, but earthquakes like 5 or 6, they'll be moderate. Okay, they can be monthly occurrence of these kind of earthquakes. Not I'm saying in a given place, but all around the world, there can be monthly occurrences of earthquake having a magnitude of 5 to 6 on the Richter scale. Okay, while in terms of population, they may repeat every 10 years, right, like that, and the movement will be strong and sudden. It will be strong and sudden. While if an earthquake is having a magnitude of 7 on the Richter scale, so that is also very rare, right? And like it can occur every 50 years although this data is basically a rough estimate, not to be considered very exact. Okay, and the devastation, it will be devastating right now. While an earthquake having a magnitude more than 7, obviously like 8, 9, or 10, so that will be having so much of destruction that will be very severe. Okay, like an earthquake having a magnitude of 8 may occur every 100 years and it will be very severe. And as follows. In the last class, I have told you that there was an earthquake of 9.5 on in Chile right now, and that was responsible for death of so many people. It triggered tsunami also in that place. Okay, so these things we have discussed. Focus of an earthquake is a point inside the Earth's surface where the earthquake originates. Focus, in some books you will find it written as hypocenter also. So don't get confused. Focus and hypocenter are being referred to the same thing. All right. Epicenter, you guys have learned about it also, that it is a point just above the focus. Okay. Now you guys take a look at this over here. See, earthquakes, we say it can be destructive and it can be constructive. What does it mean? See, constructive in the sense that whenever the plates will collide, it will lead into formation of new geographical landforms. Like take a look at the falling animation here. So here you can see the continental drift happening here. All the continents are drifting apart. Now you look at the Indian plate, how it is colliding with the Eurasian plate. As it will be colliding with the Eurasian plate, so you will see there will be accumulation of these debris over here, and slowly these debris are going to develop into the mountains. So the Himalayas that you're seeing today now, earlier what how it was formed when the Indian plate it collided with the Eurasian plate. Eurasian plate, by the way, in geography you would have learned Eurasian basically like it's from the word Eurasia. Eurasia is a collective word used for the continents Europe plus Asia together. Okay, so say that this is Asia and that is Europe. That is Europe. So this together is called as Eurasia, and that is on the Eurasian plate. So when the Indian plate hit the Eurasian plate, it led to formation of the Himalayas. So much of debris accumulated, and slowly over the course of millions of years, the Himalayas were formed. Hope you guys are catching that.
Yes, sir.
Okay. So earthquakes can lead to formation of some geographical features also. Okay, this right here is a seismograph, which is an instrument that records the seismic waves. Okay. The construction is such that it consists of a vibrating rod or pendulum that starts vibrating when tremors are felt. Like, so you can look over this spring. To this, a weight is suspended, and a pencil is attached to this. Okay. Okay. So what will happen when this entire setup will be vibrated due to an earthquake? If this entire setup will vibrate, so the pen that is suspended with this spring, it will also start to vibrate, right? And it will plot line graphs on this rotating drum. This drum can rotate. It will plot graphs. This line graph is later on analyzed. This line graph is later on analyzed, and it is then the magnitudes are uh, kind of taken out from analyzation. Understanding it now, you'll be analyzing that line graph, and after analyzation this data is ready, like whether the magnitude was 7, 5, 4, 6, 8, 9, or whatever it is. Take a look at the animation of it also over here.
We know that earthquakes cause tremors on the earth. The tremors produce waves on the surface of the earth. These are called seismic waves. Seismic waves are recorded by an instrument called the seismograph. The instrument is simply a vibrating rod or a pendulum, which starts vibrating when tremors occur. A pen or a marker is attached to the vibrating system. The pen records the seismic waves on a paper which moves under it. Trigger a mock earthquake on the table to see the seismograph in action. We can see that the pendulum tip records the earthquake on a graph sheet. In this activity, We have seen the recording of seismic waves caused by earthquakes.
Is the video stucking for you guys? Is it stucking?
No, sir.
Okay. Okay, so that line graph will be later on analyzed and then the magnitude of it is decided. Following is an excerpt from the anxiety book. Okay, so where it is written that the tremors produce waves on the surface of the earth. The tremors basically will be producing waves on the surface of the earth. These are called as seismic waves. Okay, so these waves that you're seeing here now, these are called as seismic waves. And they are recorded by an instrument called a seismograph. So the seismograph is basically recording the seismic waves. Okay, no? And this instrument is quite simple. You guys can all, if you have the right thing, you can make a setup like that. You can make a working model of it. So this is how the line graph will look like. That is a typical seismograph record. Okay. So pen basically will be recording the seismic waves. What does this pen record here? It is basically recording the seismic waves. Right now. That is the thing. Later on, this will be basically analyzed to decide what was the magnitude. Okay. Now, a very important thing about this Richter scale here, now, it's not linear in nature, meaning that if suppose there's an earthquake, one second, suppose if there's an earthquake of magnitude 1 and then there's another earthquake of magnitude 2. So it doesn't mean that the earthquake having a magnitude of 2 is twice or is double in terms of its strength, in terms of its magnitude. Getting it now? If an earthquake has a value of 2 on the Richter scale, another one is having 1, it doesn't mean that the one having a magnitude of 2 is just one more than the previous one, but rather each level is 10 times stronger than the previous level, meaning that an earthquake that has a magnitude of 2 on the Richter scale is actually 10x the previous one. Okay, similarly, if it is 2 and the another is 3, so that means it is 10x the previous one. Understanding that, everyone?
Yes, sir.
Okay. So you guys answer one question to me. If suppose there is an earthquake of magnitude 5 on the Richter scale, another is 7. So 7 is how many times greater than the magnitude 5?
Sir, 20 times.
No.
Sir, 110 times.
Sir,
Why you'll be seeing 110 times? Look over here.
11 times.
sir, 100 times.
100 times. Look here, why? Because if you were to see here an earthquake of magnitude 6, it will be 10x 5, no? It will be 10 times greater than the earthquake having magnitude 5. Okay. Then if you were to compare earthquake 6 and 7, so earthquake having magnitude 7 will be 10x the earthquake 7. Right now, it means so you're directly jumping from 5 to 7. So that will be 10 into 10. That is going to be 100 times, now 100x now. It's clear now to everyone.
Yes, sir.
Okay. So that is what is being explained here in the NCRT. That like many other scales in science, decibel is another example. Richter scale is not linear. Okay, Richter scale is not linear. This means that an earthquake of magnitude 6 does not have 1.5 times the destructive energy of an earthquake of magnitude 4. In fact, an increase of 2 in magnitude means 1,000 times more destructive energy. Therefore, an earthquake of magnitude 6 has 1,000 times more destructive energy than an earthquake of magnitude 4. Okay, no? So that is the thing over here. Look at the following image over here. So there are some zones like here basically it's being explained to you the basically the same animation moments ago which we have seen, where I have shown you how when the Indian plate collided with the Eurasian plate, so thereby Himalayas were formed. Right now, that is how the Himalayas were formed. Okay. Now there are some places in India which are more prone to earthquake. Some places in India are more prone to earthquake. Like they are more likely to be hit by an earthquake. Okay. So based on like how frequent an earthquake occurs in a given place in India or anywhere else, they are divided into different zones. They are divided into different seismic zones. Okay, so India has been divided into total of 5 seismic zones. Okay, a total of 5 seismic zones. Okay, so the one that is in very light color over here, that is faded, actually are the least active zones. While the one in the darker red color, like you can see the Kutch region of Gujarat over here, uh, parts of parts of Jammu and Kashmir, parts of Himachal Pradesh, Uttarakhand, and the whole of northeast India, some upper parts of Bihar too. They are lying in the zone 5, meaning that they are more likely to be hit by an earthquake. Understanding, everyone?
Yes, sir.
Yes.
Okay, no? So that is the thing. Okay, so let's write name of it also. Okay. Also in the history of India, there have been many, many major earthquakes. You guys are aware a bit about it. So major earthquakes in India's history. All of you would have heard about the Bhuj earthquake of 2001. I suppose many of you would have studied about it. Huh?
Yes, sir.
Okay. See, India, India has many, many earthquakes in its recent history of like 100 to 200 years. First, one major earthquake was of 1905, Kangra earthquake. Kangra earthquake. Okay. Then later, there was another earthquake of 1934. That was Bihar Nepal earthquake. It was between the border of Bihar and Nepal. Then the very famous one, that is the earthquake of 2001, that is called as the Bhuj earthquake. It occurred in the region of Gujarat actually. Okay, it occurred in the region of Gujarat actually. Okay. Then there were some other earthquakes also of the one more I will be including here. Earthquake of the year 1897. That too was very, very, very devastating actually. Once again, what happened? I mean, not visible. Guys, my screen is visible to everyone, no?
Yes,
Yes,
sir.
sir.
Okay, okay. So 1897 earthquake was also particularly like it was an earthquake in the Assam. So Assam earthquake, that too was very devastating. Then we have an earthquake in the year 1950 also. That was also in Assam. So that too was actually very, very devastating. Okay. If you talk about recent major earthquakes in the Indian history, so there has been a recent earthquake that dates back to the year 2005 in Kashmir. So these are just some of the major earthquakes, okay, in the history of India. Okay, out of that, particularly the one that was major was this 1950 Assam earthquake. That's magnitude was around 8.7, if I'm able to recall that correctly, 8.7. Okay, as for the Bhuj earthquake, it was around 7.6 or 7.7, I think. All right, everyone. So that is the thing. Okay, also, like in some cases, the focus point, no, the focus point of the earthquake may not be in the land, maybe a bit little away from the land, but the effect will be felt on the land. Okay. Now let's take a look at the falling states which are lying in the most in the zone 5 actually. Okay. So these are some earthquake prone regions of India. Okay, can you guys identify the diagram, like understand the diagram and tell me some names here? Just tell me which zones, which parts of India are in the seismic zone 5? Like they are more prone to
Gujarat.
earthquake. Gujarat, particularly the Kutch
Sir,
region in Gujarat. Continue.
So Assam, Nagaland,
Bihar,
Mizoram.
How about we simply call them
West
Northeast,
Bengal,
Northeast India? We can say that, right? Not the West Bengal. Look at the one that is in the dark zone, like in the dark color, dark red color over here. The entire northeastern states, they are actually in the zone 5. As you can see, they are in the dark red color. Then,
Sir Jammu and Kashmir, the north,
exactly, in Jammu and Kashmir. Then,
Himachal Pradesh,
Himachal Pradesh. Good.
Bihar,
Particularly, we can
does
say,
that also count?
yeah,
Is northeast?
North Bihar, we can say, North Bihar.
Oh,
And the northeast states I have written over here. Right? Okay. There's one more thing here. Look at the island in the Bay of Bengal. Look at the Andaman and Nicobar Island also.
Andaman and Nicobar.
Right? Now, so they are also lying over here. So Andaman and Nicobar Island. One thing I did told you guys in the previous class that the India's only active volcano is lying in the Andaman. Remember that. India's only active volcano is lying in the Andaman Island, and that is called as Barren Island. What do we call that? Barren Island. It's the sorry, it's the India's only.
Barren
Mhm. That is the thing. Also, you see the entire group of the Andaman and Nicobar Island is actually falling under the zone 5. Okay, that's it. Now, what are the precautions to be taken during an earthquake? So let us understand that too. Okay, the primary, very first thing that one has to do, if they can move to a safe area, if they can move to an open area, away from the buildings, away from the power lines, so their first priority should be to move to a open area where there are no buildings right now, or at least the buildings are further away from you. Okay, if suppose someone is driving, so they should pull over to safety, and they should stay inside their vehicle only right now. And the most important rule over here is that one should stay calm right now. One should stay calm and one should avoid running while the shaking is occurring. Okay. So while if someone is indoors, so they should find a clear spot away from the overhead lines and buildings. If in a car, then go to a clear spot and stay inside the car till the tremors stop. Okay. While if someone is indoors, the first previous one was outdoors. If someone is indoors, so they should stay under a heavy furniture. Okay, and not a weaker one, but a heavy furniture, like under a table till the tremors stop, and avoid staying near tall, heavy objects, because if they were to fall, you may get injured, right? So those are the protections that one can take if an earthquake has occurred right now. But suppose if someone's has to build a building which is already lying in a very seismic active zone, so thereby they need to build their buildings in accordance with that. Okay, like in the highly seismic areas, one should build mud houses with light roofs in order to minimize the damage, because the light roofs, if even if they were to fall over the person, it won't do much damage, right? Fix cupboards and shelves to the wall. During an earthquake, some buildings they may catch fire. Like if there is to be a short circuit, so building will catch fire. Getting it basically, if there's some structural damage to the building, to the wiring system in the house, so the wires, if suppose the insulation of the wire may were to break, suppose right now, so they can be a short circuit and that lead to fire also. So therefore the building must have a proper firefighting equipment also. Okay, the bare minimum thing is that everyone should have a carbon dioxide fire extinguisher at home. Okay. So take a look at this image also. One very important thing is that never ever use an elevator in case of earthquake, because if the cable of the earth of the elevator were to break, so the person is going to be in a lot of trouble right now. That is the thing. One should get under the
What
desk
if
and hold on. Mm-hmm.
So what if someone is in an elevator during the earthquake?
Hmm. If someone is still in the elevator during the earthquake, then what they can do? Interesting. See, in that situation, the first thing is that they should press the buttons for every floor to get out as soon as possible, I would say. They should be pressing the button for every floor to get out as soon as possible. Getting it? Because the first priority is to try to get out of the elevator, right now. And once the door opens, exit the elevator immediately. But suppose if the elevator becomes stuck, suppose God forbid, so then you should use the like uh, you need to report your location and wait for the rescue, right? And you can use the intercom in order to like you can use the intercom there available in the elevator in order to, I mean to say, report your location to to someone. Okay. So first thing is like press all the floor buttons, exit immediately. Also try to stay calm. Use the intercom if you're stuck. Use the intercom to report your condition, to report your location. And all one can do is will be to wait for rescue then. Getting it. That is the thing. Also, if someone were to be stuck there, why one should not panic? Because if someone is in a panic state like that elevator is already a compact area. Right now, many times if we were to be stuck in elevator for few minutes, so we start feeling suffocated. Getting it? So the reason why we start to feel suffocated is because of the limit, because the amount of oxygen starts to deplete right now. So when we are more stressed, when we won't be staying calm, so the rate of consumption of oxygen there will increase, so that may worsen the condition further. Okay, that is the thing. Okay, you guys quickly answer these questions, then we will move to the next topic.
Electroscope is a device used to measure the intensity of earthquakes.
Electroscope, it is electroscope,
Oh,
not
sorry,
seismograph.
sorry, sorry.
No issues. Does
So an
anyone?
electroscope is used to detect charge in a body.
Hmm. Okay, what about you guys? By the way, in some elevators, phone is also available. Like the wired phone is available, and some emergency buttons are also there right now. So make sure you tap it also. Or if all of that doesn't work, make sure you at least make a big, like you tap on the door in order to attract the attention of the people. Okay, not shout or tap on the door to attract attention. Okay,
Okay.
yeah. So as you said, electroscope is a device that is used to detect the presence of charge on on a body, or also to measure the intensity of measure the magnitude of charge on the body, right? What are the different layers of earth?
Sir, crust, mantle, and core.
Crust, mantle, and core. By the way, these layers have also sub layers in them, by the way. Like you
Yeah.
have outer core, inner core, right? In crust you have asthenosphere, outer mantle, inner mantle, etc.
Upper
What?
mantle, inner mantle.
Mhm, mhm. What is a seismograph?
It's a device used to measure the seismic waves. Like
Right, it's continue.
Sir, to identify seismic waves.
To record seismic waves, right? So it's an instrument that is used to record the seismic waves. Okay, it has a very simple concept of working. Basically, it has a suspended mass that will remain stationary. So when the ground will shake, right now, the recording device in it, like the pen which is attached to the spring and to a mass. So this pen will create line graphs on this rotating drum. On this rotating drum, it will create kind of a visual record. right now. And that visual record which is created here, by the way, I'm telling you one thing extra here, that is called a seismogram actually. That sheet of paper where it has recorded the motion of the seismic waves, so that is called a seismograph, by the way. Okay. By the way, nowadays modern type of seismographs are also used that actually uses electronic sensors to record the data digitally. Understanding it, the previous ones were having a setup like that where the pen would be making diagrams on it like that, but nowadays in the modern times we have got the electroscopes that uses electronic sensors actually, and that will give you a digitized information. And this type of seismographs are actually more accurate also. They are more accurate, so they will give you the digitized information that will be later on analyzed and the magnitude will be expressed. Okay, now also we can determine the source of the earthquake also with the help of this, by the way, like source of, when further calculations are done we can also determine the epicenter, hypocenter, etc. Quickly answer this one.
Surcharge.
Correct, Priyanka, Abubakar, Mustafa? Charged.
Yes,
Next.
sir, charge.
Copper wire.
Right, everyone, that is obviously copper wire since it's a conductor. Quick.
Earthquake. Sir,
Earthquake.
earthquake.
Earthquake. Next.
They
Read all
may
the
attract or
statements
repel
carefully.
depending on the type of charges that.
Okay.
So the first three.
Yeah,
Also the
everyone.
third.
Mm-hmm. Priyanka, Abubakar, why you guys aren't answering? It's a simple question. They may attract or they may repel depending on the nature of the charges present on it, on them, right? Type of charges they carry. Option C will be right answer, no? Which of the following is not likely to cause tsunami?
Lightning.
Lightning.
Fluid.
Next.
The inner core of the earth.
Sir, is it C?
Mm-hmm. Where is the shaking happening? Where is the movement happening?
Crust.
Tectonic plates
The
are moving now. That is in the crust, right? Okay. So that will be the crust of the earth actually. Okay. Although we have learned that basically if you to talk about, if you go into the reasons behind earthquakes, so there we have learned that due to the movement of the core, not movement of core, basically core will be releasing intense amount of heat into the mantle, and this convection current in the mantle which actually sets the crust into movement. The tectonic plates of the crust are into continuous movement. Even now they're actually in movement, but we don't feel them moving because the speed at which they are moving is extremely slow. Okay, by the way, you guys should be familiar of this thing also, that each year the height of the Mount Everest is actually increasing. Okay, now each year by few millimeter the height of the Mount Everest is increasing actually. Can you guess the reason? Huh? Tell me why the Mount Everest height is increasing every year. There seems to be some issue in today's class. Like it's really so much a bad network, I think. Guys, I'm properly audible to everyone, no?
Yes.
Okay. Here, I had asked a question that tell me why every year, like the height of the Mount Everest is slightly increasing.
So because of the minor earthquakes.
Be specific. Look at this diagram here. This is the Indian plate, right, Priyanka and everyone? Indian plate written over here. Okay, that is the Eurasian plate, right now. So the Indian plate is slowly moving northward and it is pushing against the Eurasian plate, right now. And this collision actually had begun millions of years ago. And that is how Mount Everest, like that is how the Himalayan mountain ranges, including the Mount Everest, was created. So the continuous pressure between the Indian plate, now the continuous pressure between the two plates, it has forced the land upward. As a result, the Himalayas, the Mount Everest, they're still rising even today. Right? And scientists actually they use GPS and satellite data to measure Everest height. And they have estimated that this increase is about one second, what happened to this pen? So that is about 1 to 2 centimeter every year. Right now. Although this can vary slightly, but it is roughly 1 to 2 centimeter every year. And if there will be some major earthquake in this region, so that can either raise or other lower parts of the mountain suddenly. Like there was an earthquake in Nepal in the year 2015. This slightly changed the average height. I hope you guys are understanding that.
Yes.
Yes, sir.
Good. Okay, what does this image tell you about?
Tsunami.
I mean,
Tsunami. Good.
that's
So tsunami is also a natural disaster. The possible causes of tsunami is two. It can be due to an like I mean, just under the ocean, earthquake under the ocean, or if there's an volcanic eruption under the ocean. Right now. So tsunami, you guys will be simply seeing this as a series of waves in the water body that will be caused due to the displacement of large volume of water, generally in an ocean or a large lake. Okay, generally in an ocean or sea, we should be saying. Okay, you know, sea. Now the causes behind this tsunami is earthquake, volcanic eruption, or if some underwater explosion have been carried out. So all of them have the potential to generate a tsunami. So when a tsunami will hit a coastal area, there'll be loss of so much of life and property. Then the tsunami will lead to rainfall also, right? And it will lead to rainfall also over here, right? So what happens? Say here, there's an earthquake under the ocean. Okay, as an earthquake will be hitting this, hitting over here. There'll be an earthquake here, so it will release huge amount of energy right now, and that huge amount of energy will displace a large volume of water. So as the large volume of water will approach towards the land, so their height increases as they reach the shallow water. So they will be gaining height right now. So sometimes they can travel up to speeds of 500 meter per hour. Okay. Also, you guys know that the continental crust is actually thicker than the oceanic crust. This right here is the oceanic crust. I have told you guys about this thing also, I believe. Let me repeat that. If this is the thickness of, suppose, the oceanic crust, no, so thereby the thickness of the continental crust will be this much. Understood, everyone? Now when we say crust,
so.
we are not referring only in relation to the land. Crust is under the oceans also, obviously, right? So as the height of this um, continental crust is more, so as the waves will approach towards the land, so they will gain height also, right now. And if you begin to see, uh, if you were to, like, there will be some warning for this also right now in the beaches. Alert systems are there. The people will be warned before the tsunami hits the coastal area. Okay, now other than that, I have said that there are possible, they can be underground volcanic eruptions too, that may also trigger a tsunami, particularly in this Pacific Ocean. You guys can see that here this circle, this highlighted portion is the ring of fire actually. So it derives its name from the fact that there are many small volcanoes like that spread across this region over here. Right now. So that is called as a ring of fire. Okay. If you were to search for videos for it, you may find some videos where you can see actually some volcanoes erupting under the ocean. You may even see the lava coming out of it. You will see bubbles and lava coming out of it. Also in this same in the same ring of fire, right, like over here in this ridge, you will find the Challenger Deep also. In this trench, I mean to say, you will find the Challenger Deep also in the Mariana Trench. It's the deepest point on Earth, deepest place on the Earth. That is Challenger Deep, located in the Mariana Trench. Okay, everyone. Trench, by the way, is a geographical feature where the land is very shallow like that. Understanding, everyone? So that is the Mariana Trench. This is what? So Mariana Trench. Okay.
Mariana Trench.
And in the Mariana Trench, you have the Challenger Deep also, right? And that is the deepest spot on Earth. Okay. Okay, so here we have finished the chapter. If you guys are having any questions, please tell me.
No, sir.
Okay, so now we are in position that we can do some questions. All right. Priyanka, do you have any questions? Abu Bakr, Mustafa? Yeah, Mustafa, tell me.
Sir, I accidentally erased it.
Please repeat again.
Sir, I accidentally erased it.
Oh, okay, okay. All right, so I'll be assigning the questions so everyone participates. First question, Priyanka, you answer. P for
Sir,
Priyanka. Next, Doha. Third, Abu Bakr. Fourth, Mustafa. Okay, start.
sir, A.
Hmm.
Sir, copper wire.
I think we had these questions moments ago. Anyways, correct.
Right.
Yes, hurry up.
Earthquake.
Earthquakes. Next. Same
This
question we have
C.
done. Next, Priyanka. Which of the following is not likely to cause tsunami? So the answer will be
D.
Doha. Earth's plate responsible for causing earthquake is.
The crust of the earth.
Okay, Abu Bakr, consider the list of terms given below: seismic zone, fault zone, mantle, and inner core. Look at the follow-up question here. The boundaries of the Earth's plates are known as. Boundaries of the Earth's plates are known as. There will be multiple options which will be correct here. Tell me. These are the four different terms. Okay. The follow-up question was the boundaries of the Earth's plates are known as. At least two options will be correct here. Anyone?
The boundaries of the earth's what?
Earth's plate. Boundaries of the tectonic plates, basically.
Sir, fault zone.
Fault zone. There's one more. Remember, fault zone is also known by another name also. Anyone? There seems to be some issue with my monitor. I think I will have to get it fixed. Like everyone's videos is stuck. Yeah, anyone? Mustafa, what about you? You answered it.
Sir, mantle.
What are you saying, Abu Bakr? Mantle? Huh? Mantle is the second layer of the Earth, no? Question is saying the boundary of the Earth's plate are known as. Look over here, all of you. Look at this image here. Look here. Haven't we learned about this? The seismic zone and the fault zone. Hmm?
So
So
I
the
can't
bond.
see your screen.
One second, 1 second. You can't see that. Let me reshare it. Guys, I think I need to switch to the computer actually. Okay, now. The next class likely will be having a class on computer. It's troubling a lot. Okay, see. So what I'm trying to say here to everyone, like these were the major tectonic plates. And the boundaries of these tectonic plates simply, they were called as seismic or fault zones. No? So that is what the question is asking. What are the boundaries of the Earth's plate called as? Clear, Abu Bakr? Well, the mantle here is the second layer of the Earth, as you guys can see over here, right? Hmm. Before we continue, you guys answer this question. List 3 states in India where earthquakes are more likely to strike.
Sir, Assam.
So the Kutch,
Jammu and
Sir,
Kashmir.
Tripura.
West Bengal,
Hmm.
Himachal Pradesh.
West Bengal is not that much likely to be hit because it does not fall in the
Oh,
seismic zone 4.
so the
Himachal.
Kutch,
Sir, Nagaland.
Kutch
Oh.
region, Gujarat. In fact, all the northeast states,
Andaman.
states, right? Okay, northern parts of Bihar also. Yeah, Priyanka?
Andaman and Nicobar.
Very good. Andaman and Nicobar Island, but that is not a state, by the way. It's a union territory. But still, we can include that as a region of India. The outermost layer of Earth is called. Very simple.
Crust.
Crust. Major earthquakes are less likely to occur in.
Rajasthan.
That is Rajasthan. Look at Orissa also over here. Orissa, run of.
Yeah, it is.
Take a look at the falling map once again, everyone here. Let's look at the map once over. Right. So that is where Odisha is, right? That is where Odisha is. This is where Rajasthan is. So some parts of Rajasthan are actually lying on the zone 3, right now. Some parts of Rajasthan is actually lying in the zone 3 and some part is actually lying in the zone 4 also. But when you look at the map of Odisha, it is less likely to be hit. Okay. So that is going to be Odisha actually, Odisha. Next.
True. Like
True.
small.
10th question. What about that? Consider the list of
Oh.
terms given below here. Earthquakes and cows.
Sir, A.
Sir,
Sir A.
Others also have to answer it quickly. Abu Bakr, answer it. Priyanka. Meanwhile, you guys answer the 11th question now.